Welcome back to Archean. This is episode 21 of Season 1 playthrough. And here's the vehicle I've been working on for the last 4 episodes, and this will be the 5th. Going to add a few more components before I start doing coding to test out the wiring and get this thing moving around a little bit. So I created a HUD controller and a beacon, and I'll use that in the future for rendering information directly on the screen itself, the graphic screen itself versus the in-game screen. Also going to create a navigation instrument, and go ahead and put a angular sensor on here. And the reason for that is sometimes there's like a pull to the left or the right, depending on terrain, when I accelerate hard. And I'm curious, at some point I can adjust for that. And we'll go ahead and remove that back there. So we'll just throw the beacon. It doesn't really matter too much, because this beacon is just to communicate data from the vessel to the HUD controller. You see, the HUD and the HUD controller, they only run on the client, not the server. And the physics and all this logic and computers and whatnot internally, they all run on the server. So you need a way to communicate between the server and the client. So the way I guess it's set up is it goes to a beacon. And the HUD controller can't access any of this wiring here because it's running on the client, not the server. But it can access transmission from a beacon. And so what you can do here is you can put information in the beacon, say in a key value string, and then the HUD controller can then pull that data and then render it on the graphic monitor. And let's go ahead and name the volume unit. I really shouldn't need the interactors. There's a bunch of data associated with that. I don't know if I'm going to need that, at least near term. And then once I have this thing closed up, I'll just go ahead and I try to read the little. This is a little different than the tilt sensor. See, the tilt sensor, you have to put 3 of them down to get all 3 axes. But with the angular velocity sensor, you only need to put 1 down, and it has all 3 built in. So I'm trying to like matching, trying to look at the display, the X and the Y, and this and that, and now it, I wish if I hit V now, it would give me the graphics so I know which way is which. It doesn't really matter too much, because what I would do is I would just like pick a value. I guess there with the wiring it showed up. Pick one, do a movement and see if it's what I expected. If it is, then I have it right. If it's not, just figure out the right one and work it out. So you can really plop it down anywhere and just work out, what is what. Or if you're careful, you plot it down, then you know the direction. So I just had a little problem reading it because it's kind of small there. Also, I want to put it at a certain location, have the port going back. I just figure out the orientation later. All right, we're doing some coding finally. All right, I'm gonna do something a little different now. So I'm creating a common XC, and I'm just gonna plop a bunch of code in here. Oh, actually a bunch of definitions in here. So these definitions are from the other runs, and what you see here is just the constants for the various channels of various components. So instead of me typing these things over and over and over and every single time I write code, I'm putting all these into a single common file. And I'm pretty sure I'm going to create a link for this so you can just download the common. if you want to plop it in there. And then I just include it like this. So now I have to repeat, the constants for the pilot seat, or, the props and wheels and whatnot. Also, the goal is go ahead and put some more generic common routines in there, so I don't have to just type those over and over and over every time I want to use them. I won't get too crazy with it. I didn't want to create one for props and one for wheels. I was going to have one called common. I say I'm not planning to put too much in there. We'll see how that goes. All right, so what I'm doing now is I'm going to basically set up, play with the hinges, make sure the hinges on the props work as expected. And this will give me two things. One, to make sure they're actually wired correctly. And then I will build a subroutine to actually retract or deploy the hinges. So we'll just do them all. We're not going to use any masking in this case. So we'll just do that for the baseline. Let's get each one. I know these are going to be, I have to invert half of these, I think. Okay, so those it deployed fully and these went up. So I just invert the right side. And that's because the orientation of the hinges are mirrored. If I had them pointing in the same direction, if I had the port on the hinge pointing to the same direction on both of them, then they had the same value. I just decided to make it a little more difficult by having the ports both pointing outwards, so that means they're inverted. Okay, so we're able to deploy. And now we're going to, we need to make sure the pivot works. And we'll just kind of do some copy pasting here. And you notice I'm not using it anymore, just using names for everything. I don't have a constant for the pivot because it's just the base value is what it is. So when it really only has like one value, convention-wise, I'll just put that 0 in there to indicate just one value. Sometimes they actually may have two, and I only care about the 0 value. All right, so they all pivoted, and the pivots all have the same orientation, so they all point the same direction. With that, this will make control interesting because that means I have full side thrusting. Now in this case, since they all point the same way, I can just do this. And they should be back to centered again. Yep. All right. So this is pretty powerful in the water, as you may guess. Besides the obvious forward, reverse movement, I can also go side to side, or actually go in any of 360 direction. And I don't have to necessarily reverse the props. I can actually just maintain the props and just spin it around. So if I want to go reverse, I can, instead of inverting the props, I can just, instead of reverting the throttle, I could move it, just point it backwards. If I want to spin in place, on yaw left and right, then, like the front can go in one direction, the rear go in a different direction. I could have them all pivot, like making like a circle, and then all spin in the same direction because they're all pivoted. So I can shape up a circle, then, then spin that way or either way too. So it all comes down to the software, is because the hardware will do quite a bit. Now the other thing that I haven't done, which I need to start doing, is there's sort of two ways to control the thrust of a prop. One is the actual thrust value, basically how much power you're dumping into the prop and how fast it goes. The other is the pitch. And the advantage of the pitch is the pitch reacts faster. And thus, for example, if I wanted to go, I was going forward and I want to reverse it, the fastest way to do that would be just invert the pitch of the prop, not to inverse the thrust itself. Because you inverse the thrust, it has to slow back down again and then speed back up again. And if you just invert the prop, I believe the speed doesn't change. You just change that prop setting. Like, for example, in the previous episode when I had the quote-unquote submarine and the forward side props all pointing up, I was speeding up and slowing down the prop, reversing the prop. And if I think I just ran the props at a certain speed and just muck with the tilt, that should respond, far more quickly. Now, you still have that issue with the power being used since you're running it. Curious if the power drops if you're like in pitch 0 and thus you don't really have any load on it. Maybe it drops down to like an idle power usage. Okay, so now that I have this sort of worked out, I'm going to put these in a little function, one called deploy props and one called retract props. This is just for now. I'm not going to get too much into the weeds of controlling the props in water, because what I really want is a mode to control each corner independently of each other corner. And for that, I'll use the sensors I mounted in each corner that will provide information whether if it's in the water or how far it is to the bottom if it's in the water. And I'll probably create some functions for that. And I'm thinking that deploy props and retract props should probably be named to deploy all props and retract all props. And then have another function that I pass the component name to. And then the subroutine that does the calc. I'll probably create additional subroutines because I do this per corner. So I'll probably create some helper functions to make that logic a little remove some redundant coding from there. All right, so we have the and I'm going to build out some infrastructure for this while I'm here. So we have a need to control the prop thrust. And I'll do the same pattern before, as I'll set up variables. I'll do this for the prop thrust, the same with the wheels, acceleration, the wheel steering, etc. And that way I can make adjustments to individual corners of the vehicle depending on what I want to do. So we'll just initially set them to 0, and then we'll sort of add different values to it based on inputs or sensors, and then finally write it out to the prop. So here, the very simple version, we set them all to 0, and then we just set the props. And I'll put stuff between, where line 22 is. More junk will go in there later. And this pattern is basically the same pattern I used before for the my last vehicle. So in writing this code is, especially writing in a new environment where like, I'm not really used to this language, and also working with the devices. So I'm getting better at it. And one is, figuring out what are these patterns that I want to use going forward to make things easier. What patterns work, what patterns don't work. And so what should happen over the series as I write more and more code, you should see the same type of code patterns appear over and over and over as I work them out. And at times I may decide that a certain pattern I don't like, and I'll just change it at some point. But okay, so I got them running slow. I didn't figure I have them running full bore. And I'm just checking. Yeah, they've got thrust. Okay, so they all got power. This looks pretty cool, I think. Really liking this system. And I'm just scratching the surface of this game. There is so much more can be done. Okay, so we want to stop, make sure they all stop running. I can just poke down there. Yep, and you notice how it's slowing down now. Okay, so we know that so our props are fully wired correctly. We control the hinges, the pivot, and the thrust of the props. And there's no braking function on the props, so it'll spin down. I guess the only braking function would be to put them in reverse. I guess if you going forward, you can slam them in reverse really fast, even at a slow reverse speed, and then go back to 0. And that should, you got to do that in different ticks though, and that should stop them pretty quickly. All right, so I had to rename those a little bit. So, because I have, I was thinking that the wheels use thrust, but the wheels use acceleration. So, but still having the prefix in there. So it's kind of funny. I use the prefix WH for wheel, but then I spell out accelerate, and then I use a previous. I could just do ACCEL, but I'm not going to claim them always consistent. And then we need one for steering. So this is the base variables that will for the wheels. So we have WH for wheel. That should make that clear. And then we have acceleration. So we want to control this acceleration and steering. And then we also got to add the brakes to this. So in this episode, I'm just going to get this thing moving to make sure the wheels go front and back. It steers. And the brakes work. And once I have all that, then I can pull it off its mount and move it around a little bit. Also, I'm gonna get a little fancy with the steering. So this steering, when you steer, it'll actually apply. So for example, if I'm turning right, it'll apply some acceleration to the left wheels, and it'll provide some negative acceleration to the right wheels. And that provides a pretty tight turning radius. Plus, when you turn, I have the front wheels, turn into turn, and the rear wheels go in the opposite direction for rear wheel steering. So all that comes into play. And we'll see, hopefully because of the size of this thing, the width and weight and all that, that flipping won't be a problem. If flipping becomes a problem, then we'll add logic for that. But right now, I just want to get this thing moving around a little bit. I'm not going to spend 6 episodes just coding. I'm going to sort of interleave it. So, for example, this is mostly a coding video. We added a few components. And then the next video, I'm going to work on a simplified OR scanner logic. Also, I'm going to start displaying things on the screen. So we'll add leveraging the dashboard in front of the seat with information, and start assuming that part doesn't go too long. Then start on the OR scanner, and this will be I'll try to make the OR scanner as simple as possible. Now I have a deeper understanding on how it works and the interaction with the pivot spinning it around. And I'm just checking the wheels, make sure all the wheels work. And they all work. And then once I have the simplified OR scanner, we'll set it for gold. And then go ahead and display that information. So it'll have a shorter range. It won't do this deep scan type thing. It'll just stay within one band. And then there's supposedly gold on land close by to this location. So I'll zip over there and track that down and do a little mining, and I'll sort of test out the mining functions, the initial, using the scanner and all that, and the anchor. I'm setting up the brake function now, because that would make the starting sequence much easier if you can get gold without going into water for a new start. Now the gold percentage is not as high as what I found, but it'd be enough to build a navigation instrument and a crafting unit. Which is funny, I can build a crafting unit, and I still haven't built that. I'm still using my suit. I'm playing with the brake function. Right now I set the brake, I'm just verifying that the brakes all work as expected. Okay, init. So if we reboot or change this, let's just put the props in default and retract them automatically. Because what will happen is, let's say I change the code while I'm in the water and, change the code. The props will initially all retract into their default position and orientation. Then the logic, it's in the system will kick in and say, oh, we're in water and we have a lot of depth, so let's deploy the props. And when we send control to steer, use the props, not the wheels, for example. So now we figured out that all the propulsion units function as expected. I can go ahead and grab some input from the seat. And once again, here in this case, you see I'm using the name seat. Normally, I would have this as a numeric port number. Yeah, on line 21, I shorten it to just forward instead of backward and forward. That's just a little too much. Now, technically, the line 22 should just be left to match the convention, but so be it. As long as I'm consistent with my own code, then it's fine. And we'll use aux4 as always. It's just my thing. I just used to hitting 4 for brakes, so pick a number. And I got an error, typo. Yep. I don't notice the typo yet, so I'll just putting the brake function in. All right, so for braking, if the brakes are applied or we're not seated, then we want to turn the brakes on. Now, instead of doing an if else, like set the brakes you have to set to 1 or 0, because if obviously we're going to turn the brakes back off. So I decided to use the try condition, and that way, so basically, if the brake is input or we're not seated, then set the brake to 1. Otherwise, set it to 0. Now, without the try condition, the other way to do it is I would need variable, $WH brake equals 0. That's a default. And then below that, if the brake is set, then set to 1, which makes, like 3 lines of code. And with this conditional and with the tri-state, tri-conditional, then you do it in 1 line. Okay, so we'll put some comments in here just so it's not a wall of code. Yeah, I think one of the first coding things is to build the build a simple vehicle. Don't add all this complexity. Build it and just get it moving and turning and all that and braking. And in this case, once again, since I use the smooth controls, I'm going to make sure there's no additional oomph coming out of that if we're braking. So if we're braking, we're just going to kill the forward motion. I'm going to go back and kill the steering factor too later on. See, I'm still focused on the coding and not looking at the message down below that there's an error. And we'll and I noticed it finally. Oh. Yeah, I thought about adding some additional logic related to the props, and decided not to put that in right now. Basically, there's some state involved, whether we're using props or not, or using the wheels. Now I'm thinking about it, state's probably going to be computed per tick. So now one thing we don't have to compute everything per tick. So for example, when a corner goes into the water and we want to deploy the prop, we don't have to do that calculation 25 times a second. We can do that once per second. And there's a case of using a timer. So like every second, check whether a given corner is in wheel mode or prop mode. And prop mode means it's deployed and we should use the prop for movement. Wheel mode, of course, I'll be using the wheels. And we do that just once a second. And that would cut down the overhead a little bit, just trying to do too much every cycle. Now, certain things we have to do every tick. So, for example, when you drill, you have to give it if you're controlling the computer, you have to set it to 1 every single tick. If you set it like once, it just stops. So basically, you have to constantly give it a value to keep the drill going every single tick. So you couldn't just set it like once per second or something like that, or wouldn't run very well. Other values you can get away with. So like if it's a state value, the internal state, for example, internal state is wheel mode or prop mode. That's my own internal state that I can set every second using a timer. All right, so what I'm doing here, I mentioned that I want to apply acceleration on the wheels during turn. And what I don't want to do is I don't make that 1-to-1. I do not want to apply the full steering value into the wheels and make them spin too quickly. So what I'm going to do is take the steering value, how hard you're steering, multiply by some constant, which is line 4, and apply that to wheel acceleration. This way, if it's too much power, I can just reduce the value. If it's not enough, I can increase the value. So generally, when you're trying to do some kind of math and you're not sure if you're doing too much or too little, you can always just add a constant to help make that adjustment. And this is gravy stuff. You don't need to do that. I just thought I'd get a little fancy. It actually works out pretty well. This thing really just turns on a dime now. All right, so we want to add to the left. I'm guessing, and I'm going to check this. I'm just thinking in my head, okay, so I'm going to the right. That value will be positive. I'm going to do it step by step. Now, what I can do is I can actually put a constant for the steering and then go ahead and look at the wheels and see how fast they're spinning. So I can do the adjustment while it's on the test stand here and not have to try to, look at it as it moves and see if it actually does that. I can also read the wheel rotation speed and display all that, but that would just be a temp thing to do. So could use print statements for that too. I'm just going to look at the wheel with a V. All right, so I know I have to make an adjustment to, and what I'm thinking is, okay, if I turn left, is that a positive or negative steering? I forget. So what I'm going to do here, I'm going to take that value and print it. Okay, so we got 0 now, and I'm trying to apply steering, D, except I'm not in the seat right now. I realize I'm not seated. I'm not seated. So we'll try to click. Okay, so if I want to go right, the value is positive. And we want to apply a positive value to the left side and a negative value to the right side. So that means line 41 and 42 would be negative. But we're going to be just extra paranoid here. So I'm going to set it to a positive value, which I know is turning right. Look at the wheels. And we can see the motor speed and the rotation speed. Now, the motor speed and the wheel rotation are different because of gearing. And I haven't got into gearing yet. And that's a whole nother useful thing to do. And you can do the gearing manually or automatic. Okay, so now I change. Let's see, I'm going to go up there and I want to negative the right side. And now these spin the same speed as last time. And these are actually spinning negative. So this thing will turn. Now if you actually have forward momentum and you turn, you'll still apply, that negative. So you still have positive, if you're moving forward at a decent speed, you still have positive movement. Just a little more positive on the left side than the right side. And of course, there's, once again, if it's too much, I'm doing too much of it, I can just change 4 or change that constant around. We don't need this anymore. I don't need that print statement anymore. I'm playing with the wheels. So I'm in the seat playing with the various controls of the seat just to goof off. That's for our HUD. And I decided to go ahead and kill the steering too if we're in brake condition. Get rid of the print. I still got to mount the nav instrument on here. I think that'd be all the sensors I'm going to need. All right, we get this thing off the test stand, and pop, make a run for it. Cool. Now I'm not actually to grab the nav unit. I guess I put it in my toolbar. And I'm going to mount it. I'm going to put a temporary platform so I get the right height before I put the deck on. And I'm going to put it back here where I can't see it while I'm in the seat. And the reason I'm doing that is that I don't want to heavily, this thing doesn't fly. And so I don't want to heavily rely on the nav unit. I just want to pull some information like lat long and try to do most of the calculations myself. This thing does a lot. It has all kinds of modes, and you can track. You can put a beacon coordinator in there and tell you exactly how to get to it. And there's all this magical stuff. I think it's actually too much. I think they should break this up into a bunch of little components and not have this mega component. Even put a suggestion for that. I noticed my cabling's getting kind of small, so I figured I'd just go ahead and make new cabling. Anywho, so I put it back here. That way I can use it for lat long, or if anything I can't get from other sensors, I can pull from here. But things like, location tracking and beacon tracking and all that, I want to do that my own and put that on the main display. So for example, for displaying lat long, I'll just pull it from the nav unit and display it on the screen that's in front of the keyboard. Now, it has different modes, and unfortunately within mode off, nothing comes out. I was hoping to be able to pull out the lat long without having the screen on, turning it on, but unfortunately we can't do that. Okay, we'll take this little bit and toss it out here. It's interesting, the first one I throw creates a box, the second one I throw doesn't. Maybe the boxes are stacked on one top each other, so that's why you don't see the second box. Okay, let's just drop the gas line, and I want this way to, God, it'd be nice if a bridge had, that's another suggestion, the bridge has a some type of data that's connected or not. Probably a very constrained scenario. Doesn't quite make, so you can only do it up to 4 meters, unfortunately, so it doesn't quite make it all the way across. More than 8 meters wide. All right, so let's put some covering on this so it doesn't look so weird. And now the props are interesting. So I was, think about covering those up from the top part. But then I realized if I'm underwater and sitting on the bottom, to like the drill or something, then I want them actually the props to go up. So effectively, if you're on the surface, they go down. But if you go in the submarine mode and go under, then they come up. That way you can sit on the bottom and the props are up, still in the water because you're underwater at this point, and motoring through it and doing that. So yeah, that's I'm not, submarine mode is not a near-term thing, and that involves this area right here, this middle floor area, which I will at some point make airtight. I'll have to flood this with water, with pumps, and then it's probably gonna need a bunch of weight. I have all that lead, and so I use that lead as add weight to it. The problem is adding all that weight. If I want to drive it around the surface, that of course makes the whole thing a lot more heavier. But potentially it could sink. I can put more junk on it and have the props come up and work that way. Let's get rid of more stuff here. And it still didn't drop the box. That's kind of interesting. I'm looking around for the other box. They should put one there. Guess not. You only have one box at a time. There's a limitation to the game. All right. It works. It goes backwards. Look at that steering. I need to go and change the grip on the wheels. The wheels are on default grip. I need to crank them all the way up. It steers. Now I'm just doing steering. See, it turns like in a circle. Look at this. So definitely got a lot more control. I need to gear it down also when you're in low speed. Gives you a little more control because it still has a little too much oomph. If I had more weight on here, probably slow it down a bit. Yeah, it's getting there. Especially when I get make that front display transparent and put some stuff on there so it's not blocking. Yeah, so I got much better maneuverability than the okay, so I actually drove it in the water purposely. I said, okay, let's want to get it wet. Now the thing is, it's not really set up yet for boat mode because I don't have these that area airtight, so it doesn't really help for buoyancy, although it floats pretty well because all that composites on there. Of course, now I'm trapped in the water, so I'm thinking, okay, do I write all the code to put the steering? It's gonna be a lot of work, and let me just we'll just take the forward and we'll manually deploy the props. I need a switch for that, and we'll just throw this into the thrust. So I'm just going to hack this in for now. It gets back on shore. And then let's just change this to deploy. We'll save that and create a new one called deploy props. Yeah, that's how you spell deploy. Must be on my keyboard. Okay. You got props down. The wheels are still spinning because I didn't disable the wheels. And there's a props kick in. Wow, we zip up. I don't have a speed indication yet. Of course, this is not helping because I'm going forward. I realized, well, let's just slam it backwards. Let's go backwards full speed, pop it up on the shore. And wow, it just... Oh, I know why, because the wheels were partly gripping on the shore too. The wheels are spinning too. So I got partial lift when I hit the shore there to get it up there. All right. Now I'm up on the prop so the wheels don't do anything. Okay, so let's go ahead and retract the props back. It is interesting that the props are deployed, the wheels are off the ground so it doesn't move, which is good. That's what I wanted. Because we'll in this mode, and we'll just turn this back off again. So definitely need some more work before we're ready for water mode. But it does go. It does float even when out the deck area enclosed. Now you add a bunch of ore to it. That's going to change that a little bit. And I'm going to move it to get a little closer so I can plug it back up and make sure the batteries stay nice and charged. All right, so we're at the end of this episode. I'm just going to go ahead and wire it back up. And until next time, see ya.